Deconfliction data, so your time of flight, center line, degrees magnetic, and your max forward time, or your max forward PM. All right, so today, what we're going to be going over, we're going to be going in depth on FDC, your Fire Direction Center. The main premise of this is going to be your computer record sheets and your computer record sheets and your M16 plotting boards. Oh, beautiful.
Oh, you got that one too.
This is yours.
I do actually.
Yeah. So,
I do.
there's the two items that we'll be utilizing, our M16 plotting boards, our range arms, and our computer records. 3 items that we'll be using. So make sure that you will find a place where you can see the board over here, and make sure you have a computer record on you. If we need more, I have more here. Also, the images of this over here. I was looking for the limited ones. Not sure where they are. And here's more computer records. That's a lot. Alright, whenever you become leadership or mortar sections, whatever, you're going to have either like a clipboard with all your information in it, or something to carry all your FTC equipment. Right? The method that I tend to do is this looks a lot like a dinner menu because it is a dinner menu. It's something that I can just slide information in and out of, and I have separate pages except for safety tees, safety diagrams. My computer record pages would be in here, and my advanced missions would be in here, all my TCMs for whatever mission I'm completing, and certain pubs on things that I need refreshers on, like the image circle. So this is where I'm going to get all my numbers and all my pages from, and then my clipboard itself is going to have everything that I need for the boards for FDC for chiefing. So it'll have all my whiz wheels. It will have my erasers, my protractors, my calculators, my map pens, pencils, and any additional computer records that I need, as well as if you have an M2 compass, having an M2 compass.
I will also let you know that is the least amount of stuff I've ever seen in that clipboard.
Yeah, because it's all around the table right now.
Yeah. If you're in that position, you will be carrying a lot. So yeah, you probably must have like 5 pounds.
Yeah, this thing is probably deadly if it got thrown at someone. So
it would definitely hurt.
Usually.
Man, I'm looking at you.
Where's that, dude?
Oh yeah.
All right. So first thing first, we're going to go over plotting board. What are our components of the plotting board? Yeah, for setting up modified observed firing chart, right? But the actual components of the board itself.
The board,
Azimuth disc, yes.
The frame.
The scale. Base. And then scale is what? Vernier scale. Vernier scale. And then additional, what's in the center? No, what's in the center?
The pivot.
The pivot point. Pivot point. All right, so this is your pivot point. We're going to be going over that today too. So now everybody should have a computer record in front of them. If you don't, get there. If there's enough copies for everybody to have one, that is for you to keep. I recommend writing in pencil on your computer record. If you don't have a pencil, figure it out. Right. So, just because we only have so many, I used to have laminated ones that I would use for practice, but as we've already stated, I'm out the door here soon, so all my stuff's packed up. All right, you're lucky that this stuff came up. So, in your computer record, you have a lot of stuff. Starting from top to bottom, left to right, you have your organization. That's the unit that's firing said mission. So whenever you receive that call for fire and your Blackfoot 81s, you're going to go ahead and in the organization and write Blackfoot 81s.
So the fire agency?
It would be the firing agency.
Yes.
Date time, it's pretty obvious. You're going to use mill standard date time. Observer ID, whatever FO is calling that mission, that's the observer ID you're going to use. Target number is going to be determined once we get into that MTO portion. So the target number is going to be a little bit later. If you guys want to, what I would recommend, this takes up a lot of space here, but it is kind of like a little cheat sheet. Have a spot where you write what I'm saying in those boxes, but make sure there's enough space for you to actually fill in and use those computer records. You can take a picture and put it in the chat.
So we have to fill out one of these here.
Every single fire machine. Every single one. At one point, I had over 100 of these computer records just sitting there because we have to maintain them for 2 to 3 years. All right? Because they are,
Government document.
yeah, they are government documents.
If
All right.
If we're gonna bother, just have a DOD number.
Okay, so you have your organization, date, time, observer ID, and target number. That is your first top line. Next, you're going to see 3 small sections there. The first section on the left-hand side has adjust fire, fire for effect, and immediate suppression. Those are going to be your different types of missions. And if it's like CAD or something, right, you're also just going to write that in. So you're just going to write CAD in that space, in that gap there. All right. Below that, you have grid, OT direction, and altitude. That is for your grid missions, your adjust fire grid. If you get the adjust fire grid, you'll put your grid, the target grid there. They'll give you the OT direction later on. And if they give you an altitude, that's where you're going to put the altitude. To the right of that, you're going to have the shift from blank. That is going to be your shift from known point missions. So grid polar shift, right? It's going to have your OT direction, altitude if they give it to you, and then your left, right, at, drop, up, down corrections that we talked about yesterday. To the right of that, you have your polar mission. All right, polar mission. It has your OT direction, altitude if it's given, its distance, and then there is a vertical interval. So if there is a altitude change, it will give, they will give you a altitude change. You have to do some math and find the vertical interval. All right, and I'll explain that later. Vertical angle, don't worry about it. That's for if they actually just give you the angle of change between them and the target. But you're not going to see any FOs do that because one, they don't know how to.
That would be like a fucking JTAG.
If you have a JTAG as an FO,
Oh, you're set.
you're in over your head.
Yeah.
All right. Below those 3 tabs there, you have the target description. Target description is the detail of the target by type, size, and protection. So SNAP, right? Size, nomenclature, activity, protection. So in the target description box, I would just write in parentheses SNAP. Below that, you have method of engagement. Your method of engagement is your type of adjustments, your ammunition that you are using or has been requested. To the right of both of those, some computer records will have a spot for the MTO. Some computer records will not. The difference is there are some computer records that were made in 2017 and then some that were made in 2019. Correction, there are some that are made in 2005 and some that are made in 2017. Both of them are still viable computer records, all right? There are benefits to some, benefits to others. All right. Method of engagement, cool. What's next on that left-hand side? Ready to go? FTC order, all right? Your FTC order starts with your mortars to fire for effect. This is just for the FTC to determine how they want to prosecute said mission. This isn't going to be set to the gun line at all. This is just for them to figure things out. So in order to fire for effect, cool, we want to use section, right? In this instance. In order to adjust, the adjusting gun 2, method of adjust, number of rounds per adjustment. So like 1 in the adjust, right? Basis for correction, if there are any correction factors. So if our basis for correction would be like a known point or a reg point, which we'll kind of briefly talk about reg points. If it's a reg point or anything like that, or net data, then we'll use that for basis for correction. Sheaf corrections is if we're changing the sheaf in any way outside of our standard, which is our standard sheaf is what? Parallel. Shell fuse is the combination that we're going to use for the mission. The type of rounds in the adjust, type of rounds in the effect. For instance, we usually tend to want to adjust in either delay or quick. So we'll do like 1 in the adjust, HED, and then 3 in the effect, HEP. You don't want to adjust in procs. Why is that? It's a little bit harder to see. Yeah, like you're not seeing a freaking dirt flowing. All you're seeing is like shotgun pellets on the ground, basically. So it's a little bit harder to adjust there. Method of fire for effect. Number and type of rounds for the effect. So once again, it's just that 3 in the effect, HED, whatever it is. Range lat spread. If we are doing the range lat spread, that's going to be where you're writing whether we're doing a range spread or a lat spread or a range lat spread. And no, my gym nerds, it is not that type of lat spread. All right. Time of opening fire. That is your when ready, at my command, TOT, or other. Other being like TTT, BPB, RAMC, that type of thing. In the middle is your initial chart data. Something to remember, your initial chart data. Think of the chart as your M16 plotting board. Chart data is your M16 plotting board. So whatever comes from your plotting board is chart data. There is such a thing as command data, which is the things that you're going to actually say to the gun line. They are 2 different things, because there are some factors that you have to account for whenever you're converting chart data to command data. So starting in the initial chart data, you have your deflection, your initial deflection from your M16 plotting board. Your deflection corrections are used for, if you have deflection corrections, that would usually be with a any type of sheaf correction that is changing the deflections of the guns, or you are doing like a range lat spread or a special sheaf or registration. All right, range, the initial range from the chart. Remember the 5 things that we pull from the plotting board, so that way we can give it to the gun line. What are those 5 things? So whenever we get our data, we parallel plot, we get our data off the linear scale, we get 2 things from that, then we use our range arm, we get 1 thing from that, and then we use our whiz wheel or our TFT, and we get 2 things from that. What are those?
Next sword.
The elevation,
Deflection, elevation, charge, time of flight.
Time on
No.
charge. Direction of fire.
No.
Time to use.
No.
Deflection, elevation, charge.
Deflection, elevation, charge, range, charge, or what else?
Elevation.
No, you already said
Time of
that.
flight.
You're missing 1.
Time of flight.
No. It's Darcy.
Direction,
Darcy
azimuth, range, charge,
has, yes, deflection, azimuth, range, charge, elevation. Yeah. It's okay.
Yeah, I mean, I know all the lyrics on it. It's just fun to be on the other side.
All right. So now you have so we take that deflection from the plotting board, we put it on our computer record. We take that range from the plotting board, put it on our computer record. It says vertical index altitude correction. Don't worry about that just yet. That's mainly for registration. And then range corrections are used for if the basis for correction is at a different altitude than the target. Charge, same thing that we pulled from our whiz drill, we're going to put that on there. The corrected range being, if there is any range corrections, then it's the result of that. Azimuth, what we pulled from the board. And then angle T. Does anybody know what angle T is? No. Okay, so angle T and the numbers 0500 to 2700 are on my freaking rock here for this. Angle T is going to be the gun target line subtracted from the OT direction. That is angle T. So basically it's the angle between what the gun's looking at the target and the observer's looking at the target. So I'm going to draw it out for you so you can see. Actually, you know what? This is kind of already here, right? So take this for instance, right? This is our observer looking at the target here. And we'll say that this is the angle that our mortars are at. Subtract the two, you find the difference. So you're going to find the angle in between. All right? That angle in between, if it is 0500 to 2700, if it is in between those two numbers, then angle T is in effect. What that means, Peters has explained it before, is remember when we talked about if your FO is looking at the target from this direction and your mortars are looking at the target from this direction, their left-rights are your add drops. Remember when we talked about that? No? Maybe? So 0500 is right about right here, and 2700 is right about right here. So anything in that fan is going to create angle T. Because anything within that angle, then their left-rights are going to be our add drops. Their left-rights are our add drops. So the only reason we actually have to take that into account is if angle T is in effect, they're going to half their corrections. Because what do we always do with our add drop corrections? We do like really broad corrections, right? We do like bracketing, that type of thing, like 100 mil or 100 meter changes. They're going to half those corrections because those are our left-rights. And we don't want to do 100 mil corrections on our left-rights like constantly, right? It's a lot of larges. We'll go over that on the board so you guys can see. All right. And then the far right side is the initial fire command. This is actually what you're going to say to your gun line. Note that this is going to look very similar to what we saw before. Man, do we have a computer record? Cool. So your initial fire command, starting with your mortar to follow that section, your shell fuse, firing HE quick. Mortar to fire is gun 2, method of fire, 1 in the adjust, 3 in the effect. And then your deflection, charge, elevation, and fuse setting. We shouldn't have any questions on that because we already know that stuff. And on that right side there, you have then your rounds expended. You're going to mark your rounds expended by each set, by each like adjustment. So that first adjustment, if it's 1 in the adjust, cool, you're going to mark 1 HE in that box. If you have the newer computer records, there's a spot for max order, time of flight, and mark time. If you do not, that's That's fine, don't worry about it. All right, at the bottom, you should see, it says observer corrections, chart safety data, and subsequent commands. All of those are all your spots for your adjustments. So your adjustments, you're gonna do your adjustments, and then you're going to basically write them in just like you would initial chart data in that box down there. And like I said, we're gonna walk through it on your guys' first mission. All right, so that is the computer record. We probably have some questions.
I have a question about the AUT. Could you explain it one more time, please? I got a little stuck when you were explaining.
Okay. Best way to put it is if I'm looking at you and you are the target, but then Perez is also looking at you and you're the target. If I'm the FO and then he's the mortar firing position, I give my left, right, and add drop corrections. They're not going to be exactly left, right, or exactly add drop for Perez. If I'm like over here, then we're at like a 90-degree angle from each other. So my left, rights are his add drops. So I'm going to half my corrections because we don't need to be doing like crazy freaking left, right corrections. Because when they look at it, they're looking at you in depth. But if I were to be like looking at it via my plots, I would be doing like crazy freaking left, right corrections.
So they're sitting us a 100 add or 100 drop. We're turning that into a 50 left, 50 right.
We're not turning it into that. They are. They're doing their
They're
own.
doing it for us.
They're having their corrections on their own.
So we don't make those corrections on the board?
No. If angle
You
T
make the adjustments.
if angle T is in effect, you notify the FOs and they'll know to have that correction.
Yeah, that's all you do. If angle T is in effect, you just say that in the MTO, like during your decon data, angle T is in effect, and then that's it. They will do everything themselves.
So you would say that in your deconclusion data.
Yeah,
Like you would look. Okay, that makes sense.
And obviously, based off of where you have the FO's position and the MFP, you could be like, oh, he's here, we're here, angle T is in effect.
you're not just gonna look at it. You're going to actually do the math by taking your direction of fire and subtracting your OT direction to actually get the angle T. Because, as I stated, and you need to have this written down, angle T is in effect if it is between 0500 and 2700. So that is this portion of measurement here. Cool. Do you have any more questions on the computer record as it stands? We're going to walk through it and like actually write in each piece. If you guys are like filling out your computer records as like a cheat sheet right now, you're probably going to either A, need another one for like a blank one, which I have extras. You're gonna write in pencil on those. That way you can reuse them. All right. Any more questions on the computer records before we go? All right. So now, the goal for today is I'm gonna get at least 2 people to do this. Okay. I have faith that more than that can do it, but expectation management, I might only be able to get 2 people to pass. So, Montez, we know this one.
We do.
We do.
Rusty'd up very, very much.
So, the goal for the end of today, I'm going to show you guys some crazy shit like advanced missions and stuff. But the goal, I want us to get a couple reps on this on the board, and I'm going to show you how to set up the plotting board in less than 60 seconds. All right. That is a standard that we as 3rd LAR hold up to. And any plotter that I've ever had has always had to meet that standard. If they don't meet that standard, they're not flying.
Once you find out what works for you, it is very easy.
So, before we get into that, we're gonna run through some of the slides so we can get some information, the basic information out of the way. And then once we get to our first scenario, I will give you an example of setting up the plotting board in less than 60 seconds. Honestly, in less than
30 is preferred, but 60 is the standard.
well, 30, yeah, nobody's done 30 yet, aside from me.
It's very hard.
All right,
Yeah, I've come close, but like not stupid close.
sure. All right, accurate and rapid computation of firing data from the LHMEC and the plotting board is important. That's why we want to set up the plotting board as quickly as possible, right? Most of this stuff doesn't really matter. The FTC of the 81 millimeter mortar platoon consists of one staff sergeant, two sergeants who are the computers, and one PFC who is the driver and RO. So if you ever get into these positions and you are less than a sergeant or a staff sergeant, you could be performing bills above your rank. So just for billing accomplishments purposes. All right. I'm not going to talk about personnel duties right now. That's something that we can go over in the future. You guys can go over on your own. Azimuth disc. We already talked about the azimuth disc, the base, the range arm, the pivot point, the vernier scale, all this stuff here.
I'll see how with the billet conference part, the quality got us going through billets, and it helped out a lot actually. It sucked, but it helped build confidence.
Yep.
So I'm not talking to John about that range. That was interesting.
All right. I accidentally talked through. Congratulations, we're skipping like 30 slides here. Because I already talked about. Yippee. All right. We're going straight into scenario one. All right. Well, here is a good example for you to here. I have this right here. So this is your mortar firing position, looking at the target. This is your FO looking at the target. The angle in which they are looking at is subtracted 2. Angle T looks like a 3200 to 2800 mils. Sorry, 0500 to 2800. Yeah. So angle T is currently in effect, just because, or sorry, 3200 minus 2800 is what? 0400? So angle T is not in effect. So angle T is not in effect because we subtracted 2. Alright. But in this instance, with this FO, if 3200 minus 1600 is what?
1600.
1600, so is angle T in effect? Alright, sweet. Angle T is in effect for that.
So IoT is in effect if it's between 0500 and 2700.
Correct.
What is, remind me again, what is that called? What would that number be?
Angle T.
No, not the angle T, but what would?
So is the
That's the
500 azimuth?
Yeah, it's well, your gun target line subtracted from your OT direction creates a number in between those two numbers. If the number is in between those two numbers, angle T is in effect. If the number is outside of those two numbers, it is not in effect.
Does it have like?
No, angle T.
If angle T is in effect or angle T is not in effect.
This is angle T.
Okay.
So think about 0500 as the left lateral limit of angle T, and 2700 as the right lateral limit of angle T.
You do your OT minus your GTL, and in between that, angle T is in effect.
Yes. All right. Side conversations down. If you have a question, ask it to the class, as well as also so that way the video can hear you, because I'm sure that you'll have the same question later.
Sorry, what is OT direction?
The observer to target.
So the observer to target. So when the observer is looking at the target, he's going to give you those left-right add drop corrections. That's going to be based on the direction that he's facing. Firing tables, I don't care. We're not doing firing tables right now. You can teach them TFTs later.
see if we can even snag with somebody, tell them what happens with ones that we had here.
I was superimposing a GI. We already talked about that. Do we remember how to create a grid intersect? Somebody give me an example of how to do it. You don't have to do it on the board, but just like give me a talk through. How to create a grid intersect on the plotting board.
Yeah, please go. You plot your position. Go ahead. You plot your position, then your target's position.
How do you plot it if you don't have a grid intersect? Are you doing it on the map or are you doing it on the plotting board? Or what's going on?
So you find it on the
You
map.
do it on the
so-
map, then you have to transfer it over to the plotting board.
Correct, but, so yeah, you plot the mortar fire position, you plot the, assumed target area.
Because we don't know the direct or the accurate location of the enemy, so we're just, first what we have on the map, we're gonna put what we have on the grid, just get the, determine our direction of fire, and once from there, we can get a rough estimate from there, and start from
Right, and then what?
You take the, I forgot what it's called, the actual circle part. The pivot point? The pivot point, and you.
What?
You move that to where the.
Okay, so
Offset.
we're on the map, we have our two plots, and then I go to the plotting board and then I offset it.
Yes.
How does that make sense?
Well, when you offset it, you're lining up your position with the target's position
On the plotting board?
on the plotting board.
I don't have them plotted yet, because I don't have a GI.
Yeah. You gotta superimpose it, so 2000, so that.
Yeah, but what's my GI? How do I figure it out? So, you have to use your protractor and find your direction to your assumed target area. Find your mounting azimuth from that direction. Your mounting azimuth. Once you have your mounting azimuth, then you can determine where you want to put your GI. So your GI is going to be 1,000 to 2,000 meters towards that target area, and then offset, so that way the pivot point isn't in the way of your target area. All right?
We used to go through, kind of just depended on certain situations. We've gone through like 3 GIs for one target. trying to
We
figure
did have to go through multiple different GIs,
out-
yes.
There's a chance we could go through anywhere from maybe at least 3 to, I think the worst one is for locational, that our worst was like 5. We're just bouncing back.
If it's like max range, it's really hard. Like if it's close to like 5,000, it's really difficult. to
Yeah.
find a good GI.
So the grid intersect is like the 2 plot points, like not the plot points, like on the map it'll say like 70
Think of your grid intersect
for your
is you are moving the map now to your plotting board.
Your grid intersect is the 4-digit grid of your pivot point. That is the best way to put it. The grid intersect is the 4-digit grid of your pivot point.
So like yesterday, it was like 1373. So you plot,
Well,
you
73
make part of the board, 13 or like 10 to 15 on
Yep.
one part, and then like 70 to 76 on the other.
Yep.
And then you would make that little section of the board your grid intersect, and then you plot your points as if it was on the map.
Correct. Yep, so that's basically correct. Just remember that to determine said grid intersect, you have to determine the direction of fire, the assumed direction of fire, and then follow that direction of fire 1 kilometer to 2 kilometers forward, offset, and then find the nearest whole 4-digit grid. Nearest whole 4-digit grid to that, that's gonna be your GI. All right, question?
You said 1373.
73 through
73 for teaching. Where did you get that from?
That was just yesterday.
This is an example.
The GI that we pulled from yesterday.
And when you pull that GI, how do I ask? How do you pull it? Based off of.
You're basically superimposing the map onto now the plotting board.
So a task for you, whenever we take our first break, you're gonna come back with a map. And then I'll explain. Okay. A little bit difficult to show you without an actual map to do it with. So
Sure.
actually, I might have a street.
The map itself will say the number, like the 4-digit grid.
And that's just what you're using?
Yeah, so you're gonna take a corner of the body board and do like 10 through 15, and then 70 through 75. And make that section of the body board like the only part you use. You're taking the part of the map that's relevant to your fire mission, put it on the plotting board, using the grid, intersection.
Wait, once we off.
Alright, so check it out. Alright. So, just take a quick look at this map, right? If I have, this, there's these two crosshairs right here, this one and this one. It's number 13 and number 15. If number 15 is my mortar firing position, and number 13 is my assumed target area, I'm going to follow the direction of fire. I'm going to go about 1 click to 2 clicks towards the direction of fire. In this case, I'll just do 1. And then I'm going to find the nearest GI, the nearest 4-digit grid that's offset. So I don't want to do this one right here because this one is online with the rest of it. I want to offset, I'm going to go like right here. So this way. Or offset this way. So then my GI would be 4999. I'm going to your map sheet.
Take that for glasses on this one. I lost mine. They said they were gonna give me a negative count or something, but nothing ever happened.
Yeah, exactly. It's this shit.
Oh.
Been too late.
Okay, so
This one's from West Coast, brother.
pardon my art. 10, 11, 12, and this one is 22, 23, 24. All right, so if we'll say my mortar firing position is right here, my target, my assumed target area is right here. I'm going to, on my map, I'm going to pull my protractor, shoot my azimuth, and it's going to be about 0800. Don't ask me how I know, I just have a freaking, yeah.
Big right.
Awesome. So I shoot my azimuth at 0800. Then I'm going to follow that azimuth 1 to 2 kilometers, and I'm going to find the nearest 4-digit grid. So this is a 4-digit grid, this is a 4-digit grid, this is also a 4-digit grid. Then I'm going to offset because I don't want my pivot point to be online with my target area in myself. So remember, your GI is the 4-digit grid of your pivot point. So wherever you put it, this is where your pivot point is going to be. So if you think about it, take a little mental picture, you throw the azimuth disc on top of this, right? Do I want my pivot point to be here? Do I want it to be here? Do I want it to be here, here, whatever? If I put it right here, if this is my pivot point, then it's putting my pivot point in line with the target. So I'm going to offset it, and I'll put it like right here. So then my circle has me to where it's offset and it's not in line with myself and the target. Does that make sense? You can also offset the opposite way. So if I put my pivot point right here, I'm still offset from the target.
Okay,
What happens if it's in line? Like, why don't you want it like in line with the target? Why do you want it?
because when you go to draw your line, the pivot point is going to be in the way.
Yeah. Oh, okay.
You can't really control it.
So now imagine, so you're thinking about it as like a cone of fire, right? This is your target area. You don't want it, you don't want your pivot point anywhere in there because what if there's a target right here,
That makes sense. Okay.
right? So you want to make sure it's out of that like cone of fire.
So you can pivot in any direction when you think it's best.
Right, yes. You don't want to go too far off remember, because this is still a circle, so you don't want to go more than like a kilometer to the left or the right, right? But now with this GI, it would be 1, 2, 2, 3. With this one, it would be 1, 1, 2, 4, because it is just a 4-digit grid. That is it.
When you're going to select the two, you want to make it to where you have the most room for your target to work with.
Yeah, you want to maximize your space. Any questions on that? Okay, are we able to move on from that?
Yes.
Do we have any questions before we get into setting up the board? All right. So, how we train to set up the plotting board is we're given a certain set of scenarios. Set of scenarios will give you all the information you need to set up your board, and then you just need to set it up in a timely manner. So being able to just do it quickly and setting up as fast as you can. Shriner, right?
Yes, sir.
Okay, cool. Just make sure you're following along. You're gonna get lost. So.
Yes.
Can I pause over pencil?
You need a pencil?
You might hop in on that, or once you must have got it.
Oh, well then, actually, Peter's is gonna hop on the board.
Peter, can you move slowly so we can understand as well?
No, so we're gonna do it fast, and then we're gonna do it slow.
I'm going real speed here.
Understood.
Let's see, pencil.
Sir.
Okay.
This is, that's what I have right
Go ahead. That's
Okay.
You want to make sure all
Yeah,
like
so, all time.
sand and shit's like off the bottom
Location.
too. That'll keep
That's
it.
it. Rubber gun's ready. This line thing, that's the NATO point. So, this is the NATO.
Fast is like 40.
So freaking, McCombs, right?
This time.
Hey, so listen up, McCombs brought up a good point. He's looking at the fire cabin displacement report publication that I put in there, or the quick smart pack. That is the NATO format in there. So what did I say was different between the NATO format and the Marine Corps format? Line echo. Line echo is different because it is the march restrictions for NATO and the round counts for Marine Corps.
I think they also do like changes to fire
They-
too.
They also don't
Hold
do.
on, that's NTO. That's NTO.
They also don't do line Alpha Bravo Charlie Delta Echo. They do line 1, 2, 3, 4, and 5. Yep. All right. So first thing first, I'm gonna need is whoever friggin' tooted walk away because it friggin' stinks.
Honesty.
Man.
No,
Have them at the door.
Your Brett's no in my coffee.
And then I don't know why you're in my box again. But. All right.
Hey, watch your step, buddy.
Somebody is going to read the scenario.
Let's go ahead.
Go ahead.
31.
I know how to read,
You're
bro.
going to read it, so that way we can actually hear you.
Yep.
And you're going to read the grids correctly. You're not gonna fucking just go through it like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You're not gonna be able to freaking write that shit down. So you are a primary plotter for an 81mm mortar section.
Good.
All right, and then I need man,
Yes, sir.
timer.
Where's that, sir?
Hold on, I gotta get set up.
After this,
Stop watch your timer, sir.
Oh, you have speakers, right?
I do.
after this, you and then 14th. Alright. Alright.
Did you want 11 Sierra November uniform,
No.
9-2?
No, there's no reason that's there.
Just read
That's
it.
my ticket. Did it go? Meyer ticket.
Are we square or what?
Yes.
It's Scenario number 1. You are a primary plotter for an 81 mortar section. Your call sign is AMC. Your position is at grid 9, 2, 1, 5, 3, 7, 1.
Oh, you just fucked it up.
You motherfucker.
Okay, it's covered up. It's covered up the last digit, so you try to fucking move it.
So now the whole shit's fucked up.
The very final digit is covered up. Wait,
Nice. It's not my fault. I could have done better.
you should have just
I've
paid
had this
it out.
PowerPoint for 4 years, and I've never had anybody fuck up the words. So.
Interesting.
Did you not see the number that was covered?
I saw it.
Autism
Just-
figures out a way.
What was the number? 4. It was not.
Yes, it was.
Well, this is what people always tell you to make and wonder what a 12 gauge tastes like.
Did you see the last number on that? Watch this. Try moving.
Never had a 7-digit group.
Can you get there? Fat. Get me, bud.
Also, don't read the entire verse.
You do have to-
So yeah, you just restart it.
No, I saw it a while ago. I just did it and let it make
This is a new version of that.
If you were to go like, can you turn the tablet towards right up? That change your
On the correlation on the page.
Yeah.
How far do you go?
There we go.
Have a target. I was like getting like their own symbol. So I'm not looking around going, what was that one?
It's all coming back. So,
So we're cleaning S3s and doing SO3 checks.
No, clean back the vehicles.
You know, when I was at LRTC, they did buy one of those handheld vacuums. This is you like that.
My shop vac, one of the big industrial ones.
Yeah, you see the fucking power. Is there a power outlet out there?
Doesn't make them bad.
Find a way to win.
Right.
Find a way to win.
Find a way to win back. Grass was not the wall, the wall.
Oh,
Grass
so
was
it's-
from the wall.
Oh, I see what you're saying.
Ugh.
I wonder how much a vacuum costs.
Yeah, you're not my least favorite guy here.
Why?
Craftsman.
what do you do?
Yeah.
I'm Milwaukee. I said ew.
Give me a snap on shop vac.
She needs to like
No, I grew up with gravel.
See, I did too.
I hate this.
See, I grew up with Craftsman, but also Milwaukee's better. So
Yeah, I say Craftsman.
I merged into it. Now I only have
You're a
Milwaukee.
convert.
Good wall.
No, I'm not a convert. I just get shit done because my tools don't break. My tools have a lifetime warranty. Very
Hey,
reliable.
Harbor Freight makes good stuff.
They'll send photos.
Shut the fuck
I've broken more Harbor Freight sockets than
Okay, I see what you're talking
Hey, what's that look?
Squirrel's too busy working.
about. So, 921537110.
That's 4.
That was 4, my bad.
Yeah.
You see that? Where's the number at?
That's 0, dumbass.
See, that's true.
Alright.
So great, we need, last digit.
What the fuck?
Yeah.
Ready? Well,
That's your good time, bro.
I'm gonna watch people. It's like, I don't know.
You are a primary plotter for a 81 mortar section. Your call sign is AMCs. Your position is at grid 9, 2, 1, 5, 3, 7, 1, 0 with an altitude of 500 meters. Your FDC chief determines your grid index to be 93/35. Your mounting azimuth is 3150 with a reverse deflection of 0, 7, 0, 0. target prefix you will be using is A, B, with target numbers 1000-1040. Your FO Avenger is located at 9275-3705 with an altitude of 450 meters. On hand, you have 300 M821A1. With the given information, set up a modified observed firing chart.
Start the timer. That is that. And done.
Yeah, it's been a hot minute for me.
You should start the timer.
So you start when you're done with that information, because we don't have everything to get the board up.
It's like 8 seconds.
Yeah.
See, I can do that, I just don't wanna show off.
Sorry, did I do like 55?
Yes. You did.
It's all coming back.
Don't worry, it's easy for me, but I don't wanna show off.
Slow. It's coming back.
Sorry. Grid.
You did?
Put that in.
Did you ever hold the hammer in your lap, son?
Actually, you know what? I did mess something up. I got the two optimum graphics wrong. I got FO in the wrong spot here. This is more practice. But the plots are correct. That's which map lives.
Wait, so Sergeant, why don't we spin like a lot in the beginning?
7.
I'll show you exactly.
Yeah, it's stuff. Yeah, it's mounting hazard. That's where he's mounting.
You know, once Pierce gets the board up.
So towards where the enemy is suspected.
Yeah.
Yeah, so those numbers are where.
Oh, no, I'm in the right spot. Alright, I'm good.
If you guys,
Oh,
you
sure.
wait, where did they write?
Oh, down here.
Down here, that's
Yeah.
what.
Yep.
In place. Yeah, no.
FO.
1, 2, 5, 6, 7. Oh, yeah, 7, 5. That counted wrong. Oh, this is an FO part, right there too.
Yeah.
Alright, found it.
Alright, sweet.
My bad.
Here's your money, Judge.
So now we're gonna walk through it slow.
What?
So, real quick, with your, you said mounting hazard, that's gonna be one that's down here, and you're gonna put,
Yes.
what were those called again that you just put down?
Azimuth equals azimuth disk. Deflection equals superimposed numbers.
So like when you read off that refer deflection was 0.7, adding down the azimuth of 3150, you're gonna put your spin to your 50, yeah, 0, and that's where you put your 0.7. That's what you're
The
going
07 was the mounting.
That wasn't the first deflection.
First selection.
Alright, cool. Do we need to see it again at speed, or do we need to see it slow and walk through?
Slow and walk through
Right.
please.
Alright, so, first thing first, before I do anything, and readers just follow along once you're done skipping.
Yep.
First thing, before I do anything, before my board is even like out of the bag, before we in place, the first thing that I'm gonna have my optimum graphics at the bottom ready to go. I'm gonna have my 81mm mortar symbol, my FO symbol, as well as my space for my GI, my space for my mounting azimuth, and my space for my reverse deflection. So I have those set up and ready to go. Alright? Once those are there, then I would be like going into my position, and we'll read off the first portion. Stop at the end of the mortar firing position.
Your position is at grid 92153710.
Okay, so all I'm doing is I'm running down my mortar firing position grid right next to the optimum graphic, and then the next piece.
With an altitude of 500 meters.
Okay, and I'm adding the altitude underneath it. And next piece.
Your FDC chief determines your grid index to be 93/35.
Alright, so note that he said, let's lock it up and lock up side conversations here. Note that he said the FTC chief determines your grid index. So your FTC chief did that whole map thing. He looked at the MFP, used his protractor, shot the azimuth, and went up that 1 to 2 clicks offset, and determine the grid intersect, all right? You determined the grid intersect to be, what was it?
9235.
Was
9335, correction.
93/35.
9335. So I'm writing 93/35 at the bottom. And then as I'm doing that, I'm also going to put it on my board. So 9335. As a reminder, it's 2,000 down from the pivot point and 2,000 left from the pivot point. So 9335, always doing eastings then northings. Eastings then northings. People are gonna get confused because they're gonna go like left to right, but it's eastings then northings. Just like how you would with any grid.
It's always 2,000.
Yes, because when it's 2,000 here, it comes to the corner and it's almost at the edge of the board. So that's therefore you're maximizing the amount of the board you can use. All right, next piece.
Your mounting azimuth is 3150 with a referred deflection of 0700.
All right, so we've determined our mounting azimuth. That FTC chief determined the mounting azimuth when he was looking, or when he shot that azimuth towards that potential target, and they went ahead and made a referred deflection. So what I'm going to do is I'm spinning my board to that mounting azimuth, and I'm going to superimpose that referred deflection on it. The same way that we did yesterday, I'm indexing 3150, and I'm going to put 07 on that spot, just like that. All right, and remember, with my deflections, is it clockwise or counterclockwise? Counterclockwise. So
Very happy to remember that.
So I'm gonna write down I'm gonna go like 400 left, 400 right. So I'm gonna do 08, I'm gonna do 09, 10, 11, and then I'm going to do 06, 05, 04, and 03. Stop.
How many are you supposed to have for left and right?
4 on each side.
4 on each side.
400.
So you got 07 from your.
07 is the referred deflection. So I spin to the mounting azimuth, and then I put the referred deflection on where the mounting azimuth is.
And that's where you just put 07.
Yeah.
Yep, and then
And
just
just
remember.
remember,
Okay.
because this one's on a 50, the rest of them have to be on a 50 as well.
So that this only matters once you get this.
Yep.
Yes. Like, yeah, so you can already know you're gonna have this, but you can't put it on the board until you get your mounting azimuth.
Cool.
That's
Now,
at 07. Facing that way now.
next piece.
The target prefix you will be using is Alpha Bravo. The target number is 1000-1040.
So, I mean, that's just your target prefectures, all right?
Yeah, you know.
Nothing crazy with that. Your target prefectures are pre-designated for LAR. Target numbers Alpha Bravo 2000 to 2099.
Your FO Avenger is located at 92753705 with an altitude of 450 meters.
So now I just wrote down the grid for my FO.
Oh, so I have a question about the elevation.
So,
I asked her
or
about
altitude.
yes, the altitude. I was asking Vermont about it, but I'm so confused on it. What's the point? Is it like an add and drop of
Up, down.
up down?
Yeah.
That's what it's used for.
It can make it to where if you are above your target, if you are at a certain elevation, you can shoot over the target. So you gotta drop. You gotta shoot like it's closer. If your target is above you, if you hit it with the normal range, you're gonna hit the side of the mountain. So you gotta aim like it's farther away than each hit.
Cool. It's best to just draw it out. So, say you've got a hill. All right, this is your hill, and this is your target right here. This is we'll also say there's another hill here. Boom. You have a mortar firing position right here. You also have a mortar firing position right here. If this mortar firing position wants to hit this guy, the elevation change is going to, say it's a 100-meter change. That's going to make it to where if they don't have an elevation change, the range will not change, so they're just gonna sit there and they're gonna hit the side of the berm. All right, so they have to make that elevation change, so that way they can actually hit the target. Same thing with this guy. If this guy wants to hit this, and it's lower elevation, he's going to sit there and hit above them. So he's got to drop that elevation, so that way he can actually hit the target. Cool. So that's why we have the altitudes, so that way we can determine if we have to make any changes.
And that's not the jump of the plotters, so like the California, that's the jump of the FTC.
Yeah, it's the job of the FTC. Moreover, like the chief would really kind of do that. So, all right, next piece.
On hand, you have 300 MA21A1. With the given information, set up a modified observed firing chart.
Okay, and then that's just telling us what round types we have. So I hope I have MA21. 60s. I think I only have one MA21.
As you all can see, like I fat fingered that. See how big that dot is? Figure that one. Yeah, that's about how big you want. I'm also fucking myself because I'm using 8.7.
So you need to use a mountain
So how much are all you?
Yes.
when you turn around the.
Yes, so like I said, whenever I got my mounting azimuth, I spun my mounting azimuth and then superimposed my referred deflection on mounting azimuth. And just like how they've been talking about this entire time, if when I get my mounting azimuth, then I'm putting my referred deflection on there. The referred deflection doesn't matter until I have my mounting azimuth, because they're going to tie together. They're going to be on that same point on the azimuth disc. So this is 3150 for azimuth, but this is also 0700 for deflection.
Sorry. You reckon I could, give it a shot? Try and get the top of the board, get the plus back up.
Yep. Next piece.
That's it.
Is it? Alright, cool. So now, once he's read off all the information, I have all the information I need, so now I'm going to set up the rest of my freaking grid here. So my GI is 9335, so at the 35 I'm gonna go up. Remember, 2 boxes is how much? 2 black boxes?
Two of them.
2 black boxes. Holy shit, 2 black boxes is a click. 2 black boxes is 1 kilometer. 3.6, 3.7. So I'm going 2 black boxes each time because I'm marking every kilometer. 3.4, 3.3. And then for 9.3, 9.2, 9.1, 9.4, 9.5. Now I have my grid set up. So now what can I do?
You can plot.
I can plot, right? Because I'm indexed on 0. My grids are set up, so now I can plot. So I'm going to go 9.2. 9.215 is, I'm on the 9.2 line. How many green boxes is that for 1.5? 3 green boxes, correct. So 9.215, and 3 green boxes over, and then 3.710. I'm going to 3.7, and then 10 is how many green boxes? 2. So 3 green boxes right, 2 green boxes up. And I'm going to make my plot right there. And my mounting azimuth is there, so I'm going to have my MFP facing that way. All right, then for my FO, it's 9275. How many green boxes is 75?
11.
That's like
Oh, shit. 75 is 750.
So 75 is 750, yes.
Should be 11.
No.
6. Oh, no, sorry.
Third.
2, 4.
All right, make it easy. So 9250 is 1 full black box, which is 10 green boxes, right?
Yes.
So I'm going to 9275, which is half of 1 black box, which is 5. So 10 plus 5 is 15. It's 15 green boxes from the 92. All right, 92, 9225, 9250, 9275. you're on 9275. We go to 37. 3705 is how many green boxes?
05.
Yes.
1. Alright, so my FO plot, 1 green box up, and there's my FO. Now I'm plotted, and I've got everything I need. I can stand by for the mission. Alright?
Well, we double check gas. We always look at the bottom and the top first. Okay, that's what I thought. That's what we should on this road.
Yeah, because you always barrel up on the bottom. Okay, cool. Any questions on that?
I just need a reminder, with the 8-digit grid, each grid box is 5.
Each green box is 50.
So, with an 8-digit grid, correct, each green box is 5. With a 10-digit grid, it's 50. And then, with an 8-digit grid, each black box is technically 50. But, as a 10-digit grid, it's 500.
I was send it from that 10-digit grid.
Yeah, honestly, I don't know why 10-digit grid isn't the standard, but like, it's easier. It's easier. Just because that's how we know. That's how we have it.
Yes.
So, all right, cool. We have that understanding. I'm gonna put us on a break. You guys have 5 minutes, and then we're going to come back, and you guys are gonna do this.
Understood.
All right, so friggin' 8:25. 8:25. Be back here.
Square the day.
You reckon I could try one?
That's what I just said. Whenever we come back, we're all gonna try it.
Shall I go to Marine?
Alright, I'll explain.
Actually, stop.
Don't forget your rocks.
Yeah.
Bring your rocks.